Students, now we will solve the next numericals which are remaining, starting from 10.6. All of you must write the statement of this numerical in your notebook as well. This numerical says that a wooden bar vibrating into the water surface in the ripple tank has a frequency of 12 Hz. So students, we are given with frequency. The resulting wave has a wavelength of 3 centimeter, that is 0.03 meter. We will convert into meter. What is the speed of the wave? We have to determine the speed of the wave when we are given with frequency and wavelength. So it's the simplest numerical because it will involve wave equation in it, and wave equation is a very simplest formula. First of all, we will write the data for frequency, that is 12 Hz, wavelength converted into meters, and students, we will apply the formula for the speed of the wave, and the resulting wave has a wavelength of 3 centimeter. What is the speed of the wave? We have to find V, that is speed of the wave. Don't get confused with the wavelength, that is 6 centimeter written. We will use wavelength which is given in the question, 3 centimeter. Examiner can change it by 6 centimeter. So wave speed is V equals to f lambda. If you substitute the value of frequency as 12 Hz and wavelength as 0.03 meter, then we will get answer V equals to 0.36 meters per second. We can also use 6 centimeter as well, but in the given numerical we will be using 0.36 meters per second. Now the next numerical we will attempt will be 10.7, but if examiner asks you to attempt it with wavelength of 6 centimeter, then you can divide 6 by 100 and you will get 0.06 meters. Because of software, student, if there is problem in writing the correct value, you can correct it. 10.7 says that it's a long numerical which is having certain parts. It says that a transverse wave produced on a spring has a frequency of 190 Hz. So students, frequency is given and travel along the length of the spring of 90 meter in 0.5 second. It is traveling along the length of the spring of 90 meter in 0.5 second. What is the speed of the wave, and what is the period of a wave, what is wavelength of the wave? We have to determine these three. Now let's see. We are given with the frequency and rest we are given with its parts, that we have to determine its time period. We have to determine speed of the wave and wavelength as well. Now first of all, we will write the data that frequency is 190 Hz, wavelength is 3 divided by 100 equals to 0.03 meter, and length of the ripple tank is 90 meter. Student, this is a very important point. यहाँ पे आप सब ने याद रखना है बेटा कि वेवलेंथ जो है वो लेंथ ऑफ द वेव है, दैट इज 0.03 मीटर्स, लेकिन जो रिपल टैंक का टोटल डिस्टेंस है, टोटल डिस्टेंस कवर्ड एल और डी, वो 90 मीटर है. 90 meter is a long distance and 0.03 meter in comparison is very small. So जो long distance है, ये total distance है, that can also be used to find speed v equals to d by t. So time is given, that is 0.5 seconds. First of all, we have to find time period, secondly we have to find velocity, and lastly we have to find wavelength. For this you can make three separate columns, students. In first column you can determine the time period, in second you can determine the velocity, and in third wavelength. So time period is simply reciprocal of frequency, so if you divide it you will get 0.01 second. We are done with time period. Velocity, we will use equation from kinematics of class 9th, v equals to d by t. So v equals to 90 over 0.5 second. So we will get v equals to 180 meter per second. So v, in the last, v equals to f lambda, we will make lambda as subject, so lambda equals to v by f. Now substituting the value of v and f, here we will substitute the value of wavelength, that is v by f, lambda equals to 180 over 190. We will get 0 point something, because 180 is smaller value and 190 is larger value. So you can see the answer, that is 0.05 meters. Now moving to the 10.8, student, you can pause the video and write all the numericals one by one. 10.8 says that water waves in a shallow dish are 6 centimeter long. So this is length of one water wave. It is 6 centimeter long. At one point the water wave moves up and down at a rate of 4.8 oscillation per second. So it is 4.8 hertz is the frequency. What is the speed of the water wave? What is the period of the water? So we have to find speed by using v equals to f lambda, and then by taking reciprocal of frequency we can find the time period. But foremost responsibility is to write data. First, on writing the data we will see, so wavelength is 6 centimeter, 6 over 100 equals to 0.06 meter. Moving to the next frequency is 4.8 hertz. This is given in the question. Now we will find the speed. You can also make two columns for finding the speed and finding the period of the water. Solution. So first of all we will write the formula for speed, v equals to f lambda, v equals to 4.8 into 0.06 and v equals to 0.29 meters per second. Time period is reciprocal of frequency. Time period equals to 1 over 4.8. Time period equals to 0.21 seconds. Now you can pause the video and write the previous problem completely. Now 10.9 seems to be a little easier numerical. At one end of the ripple tank, 80 centimeter across, this is the total length. A 5 Hz vibrator produces waves whose wavelength is 40 millimeter. So wavelength is 40 millimeter, that is 40 divided by 1000, 0.04 meter. Find the time the waves needed to cross the tank. So students, if we start, we can see that first of all we will write the data in which the total distance is 80 centimeter, the frequency is 5 Hz and wavelength is 0.04 meter. Find the time waves needed to cross the tank. We will require the time to data. First of all, we will write the distance, that is total 80 centimeter over 100. 80 over 100 equals to 0.8 meters. Students, ये total distance भी speed calculate करने के लिए use हो सकता है. On next we have frequency that is given, that is 5 hertz, and we have wavelength 40 millimeter. 40 over 1000 equals to 0.4 meter. So 40 over 1000 equals to 0.04 meter. Why? Because it was in millimeter. We have to calculate time period. We have to calculate total time. Find the time taken, total time. First of all, we will calculate velocity. V equals to f lambda. We are given with, and velocity is 0.2 meter per second. Now we will use the equation of kinematics and make t as subject. So t equals to d by v. ये इक्वेशन आपने 9th क्लास में पढ़ी है. Velocity equals to distance over time, and t time equals to distance over velocity. By substituting the value, we will get for time period, that is 4 seconds. T equals to 0.8 divided by 0.2, and when you will use these values on calculator and divide them, you will get 4 seconds. So this is the answer, and you can pause the video and write this problem as well. Now the last numerical we are going to attempt, and this last numerical is about electromagnetic waves. If you see the statement 10.10, it says that what is the wavelength of the radio waves? Student, radio waves are electromagnetic, transmitted by an FM station at 90 megahertz, where 1 mega equals to 10 to the raised power 6, and speed of the radio waves is your familiar speed of light, 3 into 10 to the raised power 8 meters per second. So now it is also a very simple formula. We will use wave equation and we will find the frequency, wavelength. What is the wavelength? First of all, we will write the data, and in the data we are given that frequency is 90 megahertz and the wave speed is 3 into 10 to the raised power 8 meters per second. Now when we will write the data, in data you can see that first of all we will write the frequency that we are given with, and then speed of the radio waves. Then it will become very easy for us to apply the wave equation and making wavelength as subject. On making wavelength as subject, we will substitute the values, and then we will able to find the wavelength. Student, remember that the numerical values are given in scientific notation, so you will use calculator. Frequency is 90 megahertz, that is 90 into 10 to the raised power 6 hertz. Velocity or speed is 3 into 10 to the raised power 8 meter per second. Now we have to calculate wavelength. So wavelength equals to frequency, wave speed equals to frequency into wavelength. Wavelength equals to wave speed over frequency. So lambda equals to 3 into 10 to the raised power 8, and lambda equals over 90 into 10 to the raised power 6. By substituting the values, we will get the right answer, that is wavelength equals to 100, and the right answer is wavelength equals to 3.33 meters. So all of you must write all the numericals in your notebook and keep on memorizing them and do the practice, because this will be included in the assessment. Everyone complete your notebook and register. We'll see you in the next class with the next topic, and we'll discussing the review question of this chapter. Thank you.